So we have seen the previous session, we have solved certain numericals based on using the concept of equilibrium conditions. We have solved certain numericals. Now we proceed further and once again solve more numericals. Yes, the problems is of this one. The given beam is of simply supported nature. The half length 2 meter, there is not a single load is acting, but for another 2 meter the UVL is acting of a nature of 10 kilonewton per meter at the center and 0 at the support B. Let us solve this particular problem. First, the modified figure, modified in the sense free body diagram, support reactions to RAH and RAV, and here the RB is the reaction. This is the conversion of equivalent point load of UVL. UVL is of 10 kilonewton per meter acting a length of 2 meter. So the area of triangle, that is half into 10 into 2, acting at the CG. The distance of CG is of 1/3 of 2 meter. So total distance from A is of 2 plus 1/3 of 2. Now using the equilibrium conditions, the first equilibrium condition, sigma H is equal to 0, not a single horizontal load is acting on the whole system, RAH comes to be 0. If we take sigma V is equal to 0, upward force RAV minus downward force half into 10 into 2 plus RB is equal to 0, and we will able to obtain one equation, RAV plus RB is equal to 10 kilonewton. We have a one equation having a two unknown RAV and RB. Our intention is to find out these two unknowns by using now the third equation, that is sigma m at any point is equal to 0. Now let us see the figure. Let's take over here this problem. Given a simply supported beam having a UVL. As the CG is over here, the equivalent point load half into 10 into 2. This is my RAV, RB. This distance is of 1/3 of 2. This is 2 meter which is given to us. So if we will take sigma MA is equal to 0, the effect of RAV is 0. Now this load half into 10 into 2 multiply by perpendicular distance from A. It is this distance, that is 2 plus 1/3 2. Creates a clockwise moment. As per our sign convention, it is positive. This is RB, creates anti-clockwise moment, RB into distance from A, perpendicular distance, is equal to 0. If we will solve these equations, we will obtain the value of RB as 6.67 kilonewton. See over here, RB comes to be 6.67 kilonewton. Place the value of RB in this equation. We will find out RAV is equal to 10 minus 6.67, that is 3.33 kilonewton. Next problem. Triangular load in this 4 meter having a UVL length of 4 meter for another 1 meter triangular load. The maximum value is of 20. Given beam is of simply supported beam. Here at A there are two reactions, RAV, RAH. At B there is a single reaction, RB. This red color shows the equivalent point load, converted equivalent point load. 20 kilonewton per meter. This is the first triangle. Equivalent point load half into 20 into 4, that is the area of triangle acting at the CG. The CG distance is of 2/3 of 4. This is another triangle. Equivalent point load half into 20 into 1. This length, see the previous figure, length is of 1 meter. Distance from the here to here is 1/3 into 1 plus 4. Using the first equilibrium condition, sigma h is equal to 0, RAH comes to be 0. If we will take the second equation, sigma v is equal to 0, then RAV upward minus half into 20 into 4 minus half into 20 into 1 plus RB is equal to 0, and we have one equation from that, that is RAV plus RB is equal to 50 kilonewton. This is having an equation having a two unknown RAV and RB. Let us use the third equilibrium equation, sigma MA is equal to 0, and we will achieve the unknown RB over here. See the figure. The figure is over here. Four meter, 1 meter, and this value, this ordinate is of 20 kilonewton per meter. This is the CG of this triangle, center of CG, centroid or center of gravity, which is acting over here. Total load half into 20 into 4. This is the CG for the second triangle, half into 20 into 1, and the corresponding distance is of 2/3 of 4. This distance is of 1/3 of 1. Now let us take a moment from A. So the effect of RAV is nullified because we are taking a moment over here. Perpendicular distance is 0. Another force is this one, half into 20 into 4 multiply by perpendicular distance 2/3 into 4 creates clockwise moment plus sign. Next, half into 20 into 1 creates clockwise moment, hence plus sign, and the distance is 4 plus 1/3 into 1. Another load RB minus RB into 5 is equal to 0. If we will solve this equation, we can find out the value of RB is of 30 kilonewton. Place the value of RB in this equation, we can find out RAV is equal to 50 minus 30 is equal to 20 kilonewton. The thing which is important over here to note down, we can take sigma MB is equal to 0 or sigma M at any other point is equal to 0. Next problem, number 9. The given beam is of simply supported beam having a combination of 3 different loads. First, UVL, second, UDL, and third, concentrated moment acting at a point. And our intention is to find out reactions at A and reactions at B. Simplified figure. It is the plot over here to understood this figure very well. The given beam is of this kind of nature. Hinge joint RAH, RAV, ruler support RB. The UDL is acting over here, UVL is acting over here, and anti-clockwise nature of concentrated moment 20 kilonewton into meter is acting at a distance of 3 meter from support A. So this is 3 meter, this is 2 meter. The UDL is of 10 kilonewton per meter. The maximum magnitude of UL is of 20 kilonewton per meter. If we will convert it in terms of the equivalent point load, half into 20 into length is of 3, and here equivalent point load for the UDL is of 10 into 2. The distance which are acting over here is one-third into 3. This distance is 2 by 2, that is of 1 meter. Now let us take a moment over here. Before taking moment, let us start with the first one, that is sigma h is equal to 0. Definitely RAH comes to be 0 because there is not a single horizontal force acting on this particular system. All are vertical forces acting, as well as the concentrated anti-clockwise moment of 20 kilonewton into meter at a distance of 3 meter from support A. Taking sigma V is equal to 0, RAV acting upward, minus half into 20 into 3 acting downward, minus 10 into 2. Careful, visualize this 20 is of nature of moment. So we do not have to use this 20 in this calculation. Sigma V is equal to 0. Plus RB is equal to 0, and we will find out one equation, that is RAV plus RB comes to be 50 kilonewton. This is the first equation that we achieve from the equilibrium condition sigma V is equal to 0. Let us take the next equilibrium condition sigma MA is equal to 0 to find out the next RB value. So now take sigma MA is equal to 0. RAV into 0, 0, RAH itself is 0, so there is no moment over here. Load is of, first load comes to be triangular load, and half into 20 into 3 is the equivalent point load. So first is the half into 20 into 3. Creates a clockwise moment. So plus sign into perpendicular distance 1/3 into 3. Now this is nothing but the concentrated moment acting over here, which is of nature of anti-clockwise, minus 20. No distance over here because direct moment has been given to us. Next, this one UDL creating clockwise moment plus 10 into 2 bracket 3 plus 1, this distance total 3 plus 1. Next force RB minus RB into 5 distance is equal to 0. Using these equations, we will easily obtain the value of RB as 18 kilonewton. By replacing the value of RB in this equation, RAB plus 18 is equal to 50. So, RAB is equal to 50 minus 18, we will achieve RA is equal to 32 kilonewton. Next solution of problem. After solving so many numericals for a simply supported beam, let us go for the next beam, and with the combination of load, a beam whose one end is fixed, another end is free, is known as cantilever beam. Students are doing majority mistakes. They are finding some reactions, I don't know how, as this is a free end and free hand doesn't have any kind of support. When there is no support, no reactions. Only at A, at this support, having a 3 reactions, that is horizontal reaction, vertical reaction and a moment which is acting at this particular joint. So now let us find out these 3 reactions using 3 equilibrium conditions. Now in this particular problem, this UVL is acting, this UVL which is acting downward. Next UDL which is also acting downward, and third, that is the concentrated moment which is acting over here. No horizontal force which is acting in this case. So if we will use sigma h is equal to 0, so RAH is automatically comes to be 0. Now using the second equation, sigma V is equal to 0. Here only one horizontal reaction is there. If you will recall the previous problem,